every AI tool that you use today traces back to a single paper. The transformer architecture, the backbone of ChatGPT, came from the paper called Attention is All You Need. The stable diffusion models or the image generation models is based on the diffusion models papers. Reading a research paper is like seeing the skeleton behind the skin, seeing the skeleton behind the tools that you're using day to day. Once you can read the paper, it means that you'll stop seeing AI as a magic trick and start seeing as the mechanics behind it. Welcome to the AI Learning Basics series. Over the past few episodes, I've walked you through how I picked up Python, how I picked up and learned machine learning libraries in Python, and the competitions that I recommend. This episode, we'll be talking about how you should choose the research paper and how you should read the paper. Today's contents, we're going in a level deeper. And honestly, I think this is one of the most important steps and episode you should remember. We're talking about reading AI research papers. I know what you're thinking, this sounds intimidating, and it is at first. But it's also one of the highest leverage skill you can build as someone who's serious about AI or who wants to understand AI. Let's start with honest question. Who should be watching this video? Who needs to read the research paper? The short answer is more people than you think, not just researchers, PhD students, or the AI engineers. However, if you're a complete beginner who just started learning what neural network is, I would recommend to bookmark this and come back. I think the basics you need to understand before diving into research paper is basic understanding about deep learning. What's the neural network? What is the activation layer? What are the layers that I can implement? With these basic understanding and kept your hands dirty with the deep learning codes, then you'll be ready to read the research paper. If you've trained a model or if you follow the PyTorch tutorial end to end or join the Kaggle competition, you're ready. And this is your next step. Where do we even start? You can start with a Google Scholar or ARXIV, where you can try to look for the treasure nicely written papers in the enormous pool. But if you're just getting started, you want a navigator, and I can share you some options. The first thing I recommend is a Hugging Face Papers. This used to be the Papers with Code for me. It was a great website, but it shut down a couple of months ago. So instead, I would highly recommend Hugging Face Papers. These days, if you go to Hugging Face Papers, I'll leave the link below. You can take a look at daily, weekly, monthly trending paper. So it saves your time thinking about what should I be reading. And the second one is an open review. Open review is a bit more advanced and leans more toward academic side. It's where the top conferences like Neural IPS or ICLR publish peer-reviewed work. It shows about the paper and what are the strengths and the weakness of this paper. So this is great if you want to grow your analytical skill, but it's quite challenging website to kick off with. And third is a social media. You'll be surprised, even in a Twitter, X, LinkedIn, there are researchers who actively share the recommended papers, the papers that they have read recently. For me, I follow like Google researchers or NVIDIA researchers regarding computer vision because I'm quite interested in those fields. You can follow the professors in your university. If you follow some people, the algorithm will automatically recommend you good people to follow. So don't be worried, just start with recommended ones. Okay, now we're moving on to how to actually read a paper, and this is where people get stuck. They open a paper, read 1 or 2 pages, and close it forever because it feels like you'll never understand. But don't panic, you can do it. I'll walk you through how you should be reading research paper 1 by looking at our example, Attention is All You Need.
So when you open the research paper, you see all the different kind of pages, as you can see, all the complicated vocabularies. It really makes you think like, how am I gonna understand this? But let's pay attention and start from the beginning. So the first thing is a title. The thing you need to bring and learn from this title is one thing, grabbing a keyword. So here the title is Attention is All You Need. This is a quite short research paper title compared to the other papers. Normally in the title of AI research paper, there are keywords that helps the readers to categorize this paper into right category. For example, it can be thing about the speech synthesis, or it can be about the speech recognition. It can be thing about the image reconstruction. This kind of different keywords, academic keywords that is related to particular AI research field is embedded inside this title. Here, from the title, the thing that you learned is that attention is our keyword. So this keyword will be everywhere in this paper. Keep that in mind. And the next thing you'll see is our authors' names. These amazing researchers. You can see this is written by Google. That's all you need to know. And now let's move on to the abstract part. If you look at the abstract, you need to divide it into 3 different sections. I've written down to help your understanding about how I read it. If you look at abstract, the beginning, the first and second sentences are mostly about the previous research. Here, even we're not going to read line by line, but you can see, oh, there is something about the dominant sequence transduction models, existing sequence-related models. They relied on recurrent and convolutional neural networks. Okay, in the previous research, the thing that we usually implemented is about CNN or RNN and the encoder and decoder. You don't need to fully understand, just follow me. And the next part that you'll see is about the main idea. It talks about we propose a new simple network architecture based solely on attention mechanism. So this transformer model they're going to introduce and talk about in this whole paper is based on attention mechanism. Attention, this was on a title, right? Yeah, so this is going to be about attention. And after this main idea, mostly on the abstract, it talks about the experiment research. I think when I first started reading paper, I tried to read and understand every line by line, but you don't really need to do that. On the experiment research part, unless you're trying to benchmark from this paper, just try to look at, what kinds of evaluation metrics they've used, what kinds of tasks did they experiment on this model, and often about how long did it take to train. Because this helps the researcher or any developers, machine learning engineers, to see if this model works better than they're working for. So this is mostly for a benchmarking purpose. In summary, in abstract, try to divide into 3 different parts. Start with a previous research, main idea, experiment research. Okay, so this paper, now we've mastered the first page. This paper, written in 2023 by the Google researchers, is going to talk about attention. We're not really sure, but it's going to talk about how they tackled the existing RNN or CNN in the sequence transduction models. Now let's move on to the next page. Okay, I've written down things here or the underline to help your understanding. Now in the introduction part. So you have to understand how introduction flows. Introduction is about building the logic to help the readers understand the background of this model. So here, recurrent neural networks. You've seen this on the very first line of the abstract. It starts off with recurrent neural networks, long-term shared memory, gated recurrent neural networks. It talks about what RNN is. But one thing you would have probably noticed is that these kind of numbers. If you have done research, you would know this is about the references. Introduction. It is full of references. It talks about the thing that the other researchers have done. So it's telling them about, we're going to talk about this, but before we introduce our ideas, you need to know about this. So in the first paragraph, it explains about RNN. And then in the next paragraph, it still talks about, RNN typically factor computation, explain about how this works. But here in the middle, the line that you need to pay attention is line like this. Problem statement. This inherently sequential nature precludes parallelization within training examples, which becomes critical at a longer sequence length. So it talks about how RNN is pretty bad at remembering the long sequence of the sentences. We're gonna tackle this problem, and then here comes our keyword, attention. Attention mechanisms have become an integral part of compelling sequence modeling and transduction models in various tasks. It shows why attention mechanism is here in the first place. There was a research about RNN, but it had this kind of issue. And there's a preceding researches about the attention mechanism. And what we are gonna do, in introduction, if you want me to pick the most important paragraph, it would definitely be the last paragraph. So in this work, we propose a transformer, a model architecture eschewing recurrence and instead relying entirely on attention mechanism to draw global dependencies between input and output. So yeah, here's the main idea. We're going to talk about transformer. It's related to the existing limitations of RNN. And we're also going to mention a bit about attention mechanism. Good. Now we have mastered our abstract introduction, and now we're moving on to background. Some of the papers named as related works but in this paper it talks about background. This background is similar to introduction, but I would say it is more detailed explanation about the existing studies. It talks about the different models here, and it talks about self-attention mechanism, intra-attention, end-to-end memory network. However, the key message they want to deliver is always on the last paragraph. It talks about the transformer is the first transduction model relying entirely on self-attention to compute representations of input and output without using sequence, aligned RNNs, or convolution. This is what they want to say. It's talking about how great, unprecedented creative idea they are. And now that we have built up what we're going to talk about in a background related works and introduction, it moves on to the model architecture. This is the key creative part, the key idea that you need to understand in this paper. Mostly this model architecture, it comes with this kind of overview figure of how the model looks like. I'm sure you would have seen this somewhere, how the transformer looks like, the encoder, decoder part, and different kinds of layer. But here, when you read it for the first time, it's very difficult to understand what it is. Mostly what I do is focus on these paintings. I'll just go through, what's the input? How does the output comes out? And how is it interconnected? And the reason why this architecture overview is on top of this model architecture part is because to help the readers understand how it goes on. 3.1, it goes through encoder and decoder stacks. It talks about the bigger layer. It talks about the encoder. It talks about the decoder stack. This model architecture is usually followed by the mathematical formulas. It goes through the equation about how this mechanism is calculated, the theoretical part behind these models. In this case, there are multiple formulas, but I'm not going to go through that mainly. So here, if you look at the big titles, positional encoding, feed-forward network, application of our model, multi-head. If you read through all the model architecture, reading through understanding all this formula, it goes back to they experimented. So this big section is about the training. How they trained it is more of a practical part. This would be more helpful for any developers or machine learning engineers trying to look up what kind of data set they use, how big the data set is, how they constructed different data set. This is quite useful when you're joining some competition or you're trying to develop your model on your own. If it's a massive data set, understanding how big this hardware is, what kind of GPU they used, it really matters a lot. And it talks about the optimizer. If you have studied deep learning, optimizer is one of the key things that you need to choose to train the model. Regularization. And after they give a brief info like this about the training info, it jumps to the results. They've also added some extra category like modal variation, showing how they set the different parameters here and then how it resulted in these measures. Okay. After they show all the training validation results and their variations, it jumps to the conclusion. It talks about, we've talked about the transformer. In this translation task, based on our experiment results, it shows that transformer can be trained significantly faster than architectures compared to RNN or CNN. And it achieved this new state of the art in a translation task and giving them a GitHub code. So now can you see the structure of how this research paper flows? Let's go back from the beginning and understand how it goes through. On the first page, look at the title and grab the keyword. I call it as a keyword-based hunting. If you look at the keyword, try to look for the keyword. Beginning from the abstract, on the first two paragraphs, focus on the previous research. On the middle part, main idea, and the last part is experiment research. As we've seen before, you'll have a chance to take a look at this experiment research in the last part. So when you're first reading a paper, focus on abstract, introduction, and take a brief look on background. If you try to understand every single detail on a background or related works, it'll take you forever. And then after you understand what the keyword is, what the problem they're trying to solve, move on to the model architecture. Jump to this figure first. The rest of the part is mostly explaining about one by one. It explains about encoder and decoder. It talks about the feed-forward network here. It talks about the attention mechanism hidden inside. In this model architecture, it shows mathematical formula, theoretical background about all this mechanism. You move on to the next part, the training part. On the training part, you can see what kind of thing they engineered, what kind of settings they have used in this training, what kind of data set, what kind of GPU, what kind of optimizer, what kind of regularization, and what kind of results they have achieved, what kind of variations they've tried, and the conclusion.
Thank you for following my step-by-step guideline of how I read the research paper. Hope this was really helpful. Here's something that I really want you to hear, but I also hope someone told me earlier. The first time you read a paper, you will have no idea what it's talking about. And that is completely 100% normal. I've spoken to PhD students, AI researchers, and then they also have no idea how to understand those research paper at once, because this research paper is something that researchers have delved into a couple of months, sometimes years. How can you possibly understand this paper at once? We're not Einstein. So my personal approach is, first, find a paper that genuinely interests you. Not one I feel like I should read, but something that makes you curious. For example, when I was starting reading a research paper, I was really interested in image generation. And one of the neural network model that fascinated me was called generative adversarial network. It's a GAN model series. So I looked into the main paper of a original GAN model and look into the connected paper, 2 or 3 papers like conditional GAN or style GAN, how they modified different ideas. So when you choose these papers that you're interested in, I recommend you reading at least 5 to 10 times over days or weeks. It is not an easy process, but if you choose the area that you're interested in and try to understand each line, what it's talking about, what's the key idea, it'll definitely make you push forward. And once you've worked through one paper that you love, then move on to the next paper. You can read the paper's reference inside this paper or any paper that interests you in a Hugging Face or in a social media someone recommended. Try to dabble in and learn what they are talking about. If you're generally not sure which paper you should be picking, don't worry, I'll try to put together some list of recommendations and put it on the description below. Someone told me it's quite difficult to look at the blog post, but I left the Medium blog post with the friend link that anyone can take a look. If you have any difficulty, just let me know. Now that you know how to read the paper, what's the natural next step? The next step is about how to turn these ideas written in the research paper into the PyTorch code. In the next episode, I'm going to show you how I use my favorite research paper or a popular research paper to level up my PyTorch skill. If this video was helpful, please share it. Someone who's been thinking about getting serious with AI or feels completely lost how to read the paper. Thank you for watching, and I'll see you next time.